Okay, and then I have got that up.
So one difficulty I encountered is when I tried to connect the PC to the switch, it wouldn't let me select which fast Ethernet port to pick. It would go in order 0, 1, 2, 3. It's, so then I had to change the VLANs back
Okay,
to
all right,
1, 2,
so
3. It became a mess.
all right. So let's look. Whoops, someone's got me on an echo there. It's bad enough hearing me once. You don't want to hear me twice.
Oh, it's like live talk radio. I get it. But no 5-second delay.
Yeah. Okay, so we're good now. Looks like it. All right, let me get back here to the Zoom. And I'm going to share my screen is what I'm going to do. This, what I should be doing. Okay, everybody can now see the scenario, correct? We're all
Correct.
good. Yeah. Okay, good. All right, so what Roger's asking about is inter-VLAN routing, and we're going to look at this right here, router 1, building 2, because we're going to do it on a multi-layer switch. So this one, that's a multi-layer switch. And we have VLAN 30 coming in and VLAN 40. And we want to be able to route between VLAN 30 and VLAN 40. Okay. So let's open this up. And we already have, I believe, have it configured. But let's just get in here. Let's do a show run. I'm going to see if we have this thing already configured because I think it. Okay, that's for that. Yes, we do have it. Okay. So I'm going to show you this configuration here. What we need to do in order to route for VLAN 30 on a multi-layer switch, what you want to do is create a virtual interface, a VLAN interface for that particular VLAN that you want that interface to be part of. So here we go, interface VLAN 30. A MAC address is assigned to it by the switch. It's a virtual interface, so it does not actually have a physical MAC address associated with it. Does anybody have any question about that aspect right there? Because that's the most important concept here. It's a virtual interface, software interface. Okay. All right. So now that when we go interface VLAN 30, enter that as a command, we actually create the software interface. We then give it an IP address, and we want to give it an IP address in the VLAN 30 subnet. And in this case, I decided that the VLAN 30 subnet should be 172.16.30.0 with a mask of 255.255.255.0. And I gave this interface the .1 host address in that subnet. So now I have a VLAN 30 interface, and then I go down and do the same thing again. And these are all commands that I entered in. Actually, not all. I didn't enter in the MAC address command. That was automatic. Then I interface VLAN 40 and give it an IP address in the VLAN in which it's going to serve. And that subnet was 172.16.40.0. So I made this the host .1 host in that subnet. At that point, when I assign devices into VLAN 30 and into VLAN 40, inter-VLAN routing is accomplished. Okay. And let me just come up here though and show you a couple other things that I did. Okay, so I want to have a device out there, one of the workstations. If I pull this aside, we can see that. Let me see here. We'll have to scroll this down. Okay, so here we go. So PC 11 is in VLAN 30 in this design here. There's a access layer switch there that it's connected to. But what I have up here is I want to have this particular port go out to VLAN 30. So what I do is whatever that port is, and if we look at the configuration here, we see that port is interface FA0/3. That's just one that I decided. So what we have then is over here, we have, that would be interface FA0/3. I made that an access port. I didn't need to make it a trunk. Had I wanted to support multiple VLANs off of this switch here, I could have then made that a trunk. And of course, if it's a trunk, it supports VLAN 30 and 40, and it supports all VLANs. So at that point, it would not have been a problem. But what I basically have then is a virtual interface up here. I have the link down here to this switch. That link is also going to be in VLAN 30. On this switch, I could create VLAN 30, or if I'm using VTP, VLAN trunking protocol, I actually could have created it up here and just had it propagated down. But in any case, VLAN 30 has to exist up here. VLAN 30 has to exist down here. This port is in VLAN 30 on each end, and this port is in VLAN 30 connected to the PC. So then to make this all work, I give the virtual address, virtual interface and address, and then come down here to the PC. Let's go down to the PC. And at the PC, okay, well, what I would want to do if I'm going to interface, configure this statically, I would put the default gateway to 172.16.30.1. And then I would go over to Fast Ethernet 0. If I'm not using DHCP again, if I was using DHCP, then this would have been taken care of. IP4 address 172.16.30. Let's say 11. PC 11, we'll give it .11. And then we have to give it the mask. Okay. And then we go to the desktop and we'll verify this. I'll do this with an IP config. There we see we have our addressing. And now let's see if I can ping my default gateway, 172.16.30.1. Let's see if everything's functional up through that environment there. So if it's not, which it doesn't seem to be right now, then I would next check the intervening switch that's between the two of them and make sure that everything was correct on that switch. My guess is that right now the switch is not configured. So I'm going to close this down. I'm going to open up this switch here and go to the CLI. And so I've got FA01 and FA03. I'm expecting that I'm going to want both of those in VLAN 30. Let's just see if we have VLAN 30 here. Show VLAN. Okay. I don't have a VLAN 30. Oh, yes, I do. There's VLAN 30 down there. I see it. VLAN 30. Okay. But no ports are in it. So now what I'm going to do is go config T interface FA0/1. That was the one pointing up. You see that right up here, FA0/1. 0/1, enter. And this is going to be an access since we're not trying to do trunking up to the switch up above. Switch port mode access. Okay. Oh, so I wonder if I have it as a trunk. Looks like it might be a trunk going up there, which would be fine, but let's just do this. Control Z, it didn't like that. Let's do a show int interfaces trunk. Let's see if it's a trunk. Let's see. Well, that's FA03 is a trunk. That is, oh, FA03 is pointing. Well, let's do a show CDP. This is where CDP comes in. Show CDP. What do we have out? Show CDP neighbor. Okay. And so our local interface FA01 points to up to the switch up above, but I don't see that as a trunk. Let's see, FA03. And ours is on FA01. So let's just try and do this. Let's see, blocking fast Ethernet, inconsistent port type. 01. I'm trying to see why this is doing this. We might have, well, let's do this. Let's get FA03. I'm going to go interface FA0/3. And again, it may be just a matter of making sure I get the right ports connected to the right PCs. So this should be the one that would be connected to the PC. Switch port mode access. Okay. And then switch port access VLAN 30. Okay. Control Z. So that should work. Now, do a show int trunk. We shouldn't have any trunks now. Show int trunk. No trunks. Okay. Let's do a show. I'm gonna do a show VLAN again. I'm trying to troubleshoot and see what. Okay. So FA01 is in VLAN 1, but we don't want that. Oh, I know what's going on. No, I'm sorry. I take that back. I'm on the access layers, on the access layer switch. Why would FA01? Let's do, I'm gonna do a show run again, just see what we've got. FA01 is, oh, it's okay, now it's access. I should be able to put it into VLAN 30, so config. Yeah, I don't know what the error message was then. Interface FA0/1, and then switch port access VLAN 30. There we go. Okay. Now, let's do a show CDP neighbor. I just want to see if we're all right. So FA03 up there, FA03 tried to be a trunk at the other end. We don't want that. So we'd want to make that into a switch port, an access port. So let's close this. Let's go up here and see if we can turn FA03 interface FA0/3 switch port mode access switch port access VLAN 30. There we go. Now let's do a show CDP neighbor from here. And out FA03, what we see is another switch. Out FA04. Okay. We're getting a lot of different information there. Okay, so now let's come down here and see whether or not, because I think now we've fixed all that. Let's go down here. Let's go to our command prompt and let's try a ping again. And now it works. Okay, so that's what it was. We just needed to assign the ports to the proper VLAN along the way. That's the problem that we were having. So now we've got the ability of this machine here, this PC, can now communicate up to there. Let's see whether that PC can reach, rather than, I want to do that again. Let's see if that PC can reach the other subnet, which is 40.1. So that's the other virtual interface, and that works. So right now, I've just demonstrated inter VLAN routing. Even though I'm not going over to the other PC yet, I've shown that I can get from my subnet, the 30.0 subnet, over to the 40.0 subnet. So I am doing inter VLAN routing. All right. So on this router here, what I had to do a show run again. By the way, this would be a command you would turn on before you set up any of this routing. You want to do IP routing that turns it on a multi-layer switch.
So that is the command I tried to issue and it didn't give me syntax error. So what level do you
If I was
actually?
going to issue the IP routing, I would go config T right there, IP routing.
That's what I did. Let me,
Now, if you did that on a multi-layer switch,
yeah.
you shouldn't have got an error. If you did that on a layer 2 switch, it shouldn't have worked.
Okay, so let me go to my scenario here, the multi-layer switch. CLI. Oh, enable config T. Oops, config T. And it's IP address or what's
No,
it?
IP routing.
Okay, IP routing. Oh, okay, it did work.
Okay. All right. So IP routing is the initial command to enable routing on a multi-layer switch. Then, as we were looking at above, show run, we have to go down to here. This is what we have to do, is configure a virtual interface for every VLAN that we want to support. And of course, we have to create the VLANs on this switch. You can actually, if you create the virtual interface, I believe you have to create the VLAN first, but you also have to put a port into that VLAN for that interface to work. If there's not some port on the switch, physical port on the switch in the VLAN in which you've created the software interface, it won't do you any good. Okay. Any question on that? So what I did on this limb right here, I would then do that over here as well. I would go to this PC and I would guess that this PC is also not configured. It's not, so I would configure that. And then I would go to this switch here and make sure it was configured. And I do a show run, see if it's configured. It doesn't look like it's configured because there are no ports on this switch that are in VLAN 40. If I do a show VLAN, there is no VLAN 40 either. So I'd have to create VLAN 40, put ports in VLAN 40, etc. Do you folks want to do that and with this scenario right now and just get it so that you have routing from here all the way up to there? Wouldn't be bad practice. You should be able to knock that out Well, let's put it this way. If you are able to do it without any problem, that's good. If you're not able to do it without, significant practice or work, that's probably also good, because then it's good practice for you to make that happen.
Personally, I'd rather just do it on a very small scale rather than all those.
Well, okay, so you are doing it on a small scale. You're just right here. You're in one building, 2 VLANs. You really can't do anything any smaller than that, except that this is plugged into a larger environment. But what's happening out here is irrelevant to the routing that's occurring in here. Does that make sense?
I just tried it on the one I gave you with the multi-layer switch. I tried to ping from one PC to the other PC and it didn't work. So
Okay. Well, do you want me to continue on with this scenario and make this whole thing work right here? Because this is, I mean, you have to have the inter-VLAN routing. You have to have 2 VLANs. We have 2 VLANs. If you want to do it off a multi-layer switch, you have one multi-layer switch. You have to use virtual interfaces. We've got virtual interfaces, and so forth. I
wouldn't mind if you just got one multi-layer switch and try to set up from scratch. Because when I try to set it up and I did the connection between the PC and the switch, it wouldn't allow me to pick the port.
Okay,
Everywhere
okay.
else,
So I see you're there at that point. So let's do this. I'm going to do a save as, let's see. No, I'm just going to save this. And then I'm going to do a file new. Okay, so what you want to do is put a multi-layer switch here. Let's see which ones we
so
there we go, right there.
Multi-layer switch.
So let's see, which is a multi-layer switch? I think the 3650 is what I was using up there, right? So there's a multi-layer switch.
I use a 3560. Does it make a difference?
Well, if they're both look like they're multi-layer switches, let me just put up one of theirs and I'll do that, and I'll just hang on, I'll just delete that. Okay, so now I've got a 3560. Okay, so now I'm going, actually now what I want to do is put some PCs out there. So I'm going to put just a regular old PC here. And a regular old PC out there. Now I could do it with this. I don't need a switch in between the two of them. But normally you do not have workstations hanging off of a layer, distribution layer switch. However, let's say this was the situation what you had, and someday this actually may become more prevalent, because as multi-layer switches become less expensive, the layer 2 switches won't make as much sense. So let's just go ahead and set this up right now so that this all works. That means that I'm going to go directly from there to there and there to there. I'm going to cable that, and I'm going to cable that with a straight through. And I'm
is that my error then? Oh,
I don't know. I don't know what your error is. I can't see it, but so FA01, FA0.
So I picked the lightning bolt.
Oh yeah, no, that won't work because that's not the right kind of cable. So FA02.
Why does that not work?
That's not an Ethernet cable.
I thought the purpose of the lightning bolt is that it'll pick for you.
So did I.
I've never tried this. I've never tried a lightning bolt. Let's see here. No, can't be connected. So there you go. It's connected to a port there. Now it's got to be connected to something else. Let's do an escape there. So let's put another PC out there.
Okay, so which cabling do you pick then?
Straight through is that one right there. That's the straight through cable, the solid line.
What exactly is the straight through cable in this sense then?
Okay, an Ethernet is straight through cable is one,
Okay.
I'm sorry?
Okay, so it's just an Ethernet cable, like
It's just a standard Ethernet cable. You have
okay.
two basic types, straight through and crossover.
And the lightning bolt, if you pick that, what kind of cabling does it pick?
Well, let's see. I don't know what it is. Like I said, I've never tried that. Let's go there. Let's see what it did. Did it go to fast Ethernet? And maybe it did.
It picks the lowest port. It picks the lowest open port.
Maybe so.
So what kind of cabling is that?
Well, then it probably did an automatic. It looks like it's auto. It looks like it took, let me just put an IP address here, 172.16. Well, we were working with 30 and 40. We'll go 40.10. And we're going to go with a 255. Okay. All right, whoops. Back down to there. And now I'll see. I'm going to do an IP config and see what it actually. So it says, yes, fast Ethernet. So it went to fast Ethernet on that one. Let's go up to the switch and CLI. It looks like, yep, it picked. Boy, I don't want to do yes there. I'm going to do no. Okay, it looks like it picked FA03. So
if you just hover over the switch and don't click, it shows you everything.
well, it does. I have trouble sometimes getting it to do that. I have to hover in the right place. Yeah, I'm not getting any.
Oh, is it different on the PC then?
Well, no, but I'm saying that normally on the switch, if you hover over a port, I've had it come. Oh, there it did there for just a second. I'd have to hover just in the right place. So I don't, that's sort of frustrating to me. There it is. Bingo. So
Yeah.
FA0, 1, 2, and 3 are up, up, and up in VLAN 1. Well, of course, that won't work. We have to put them in different VLANs. 1, 2, and 3. If we want to have inter VLAN routing, we want those to be in different VLANs. Does this answer your question for you, or do you want me to continue and configure this scenario?
I wouldn't mind if you finish it just with two of them. At least you fix up one of the difficulties I had.
Okay, so let's do this. I'm going to create 3 VLANs, okay? VLAN 20.
Two's enough.
Huh? Okay, I've got, this is, I think, 40. Let's see, what did I give this thing in the way of an address? I gave this 40. Okay, I'll just do VLANs 30 and 40, okay? And what I'll do is I'll delete this one. Just delete that one. Okay, so now I've got these two machines. This is going to be in VLAN 30. So the fast Ethernet is going to be 172.16.30.10. And then we've got, I think we got there. Okay, so bingo. All right. So now I've got, do an IP config to confirm that. IP config will be something that's tested on the test for you. So there we go. No default gateway. So without a default gateway, I cannot do inter VLAN routing, but I'll fix that later. So now let's come up here in the switch. And let's go through our steps. Okay, so config T. First thing I'm going to do is IP routing. Not touting, but routing. And then I'm going to create my VLANs, VLAN 30 and VLAN 40. Okay. I'm going to exit one level here, just didn't have to, but I'm going to go interface, VLAN 30, then IP address, 172.16.30.1, 255.255.255.0, enter. It automatically changes state to up, so I don't have to do a no shut on this. I now can go up arrow, and change that to 40, interface VLAN 40, enter. Up arrow, and I'm going to give this an IP address of 40.1. Enter. Control Z. I'm going to do a show IP route, and I should have in my network. Oh, I don't have anything in my network. What happened? Well, I don't have any interfaces on the switch in VLAN 30 or VLAN 40. So I have to now create those interfaces. And I think if we saw that FA01 was off to one PC, so that would be config T int FA0/1, and that's going to be a switch port mode access and switch port access VLAN 30. I'm sorry, 30. Bingo. And then I'll go interface FA0/3 because 2 went to the PC I just deleted. And I'll go switch port access VLAN 40. Bingo. Control Z. And now I'll do a show IP route and see if I have any happier situation here. And there we go. So now we have the two networks. Okay. Now let's go down to my PC. Command prompt. We don't have a default gateway. So we can ping though 172.16.30.1. Okay, we can, but we can't ping 40.1, even though it's right there in the switch. Can't ping it. That makes sense because we don't have a default gateway. Without a default gateway, you cannot, oops, I wanted to do that. I'm sorry. Want to go to the config, and my default gateway should be 172.16.30.1. Okay, I'll now go to my desktop command prompt. Let's just see here. I'll go IP config just to confirm it. Okay, so now I have that, and I should be able to ping 40.1, and I can.
So that's what I missed. The
Well, it's all the components put together. So if we were to walk through those components on the workstation, I had to have two things: a default gateway and an IP address with a mask. That's on the workstation. On the switch, I needed a number of things, and let's go through that. Show run. I needed IP routing. Okay.
okay.
I needed to create the VLANs 30 and 40, and then put these interfaces, that interface is in VLAN 30. That interface is in VLAN 40. And then I had to create this, the virtual interfaces and give them IP addresses.
You know, I spent about 3 days on this.
Okay. Well, I understand that, you know, this is how things are in the world. You know, figuring out exactly what the command is the challenge. Once you know, you say, oh, that's simple. And it is simple if you know what to type in there. But until you know, there's nothing about this that is intuitive, absolutely nothing whatsoever. So, you know, and hopefully that's the value of having an instructor in a class, is that I can save you some time. It's really all the information to do what we're doing in this class is out there somewhere. But having an instructor that can sort of direct you to it helps shortcut that process. I mean, I know I've had many textbooks for the world of networking that I've read, and a lot of them are just unfathomable. You just can't figure out what the heck. So then you have to get out there and actually, sort it out and figure it out. But so that's that's the value of having,
So what did you set the default gateway from the PC?
on the PC. The minimum configuration for a PC to go. Okay, let's try this. The minimum configuration on a PC to communicate with other devices on its own network is its own IP address and mask. Okay. But to get off its local network, it also needs a default gateway.
So you can go from PC 0 to PC whatever
2.
1. Right now, PC 1 does not have a default gateway, so it can't go the other way. Is that correct?
You mean PC 2? Yes, that is true.
Okay.
So at PC 2, you see here, there's no default gateway. It can communicate with its own, with the switch. It can actually ping the switch now, I believe. It should be able to do that. Ping 172.16.40.1. Yeah, no problem. That would be what we'd expect. But it can't even communicate with the other virtual interface on that switch because it has no default gateway.
Okay.
Okay.
I don't know how long I would have spent working on this.
I don't know, but this is what it's a slow process. IP addressing, IP routing, none of it is intuitive. It's just a slow process of simulation, but that's the basics right there.
Okay.
Okay.
Thank you very much.
You're welcome. Glad that helped. All right, now what we're going to do next is I'm going to stop this share, and we're going to go to IP addressing, because what we're going to want to get to is where is it? I had a slide up here. I don't see the slide. Okay, so the slide must not be okay. Hang on. I'm going to bring the slide up. Okie dokie. And now I can share it. And this is a big part of your exam. We'll come around IP addressing and subnetting. Okay. All right, so we're going to start in on this, then we'll take a break and continue on. We're going to look at IP addressing, which we've covered. So this is going to initially be review. And then we're going to look at IP subnetting, which we've covered a little bit. And then we're going to look at variable length subnet masking. And that is an area on the test that they like to get you on. You'll have probably more than, I would say very easily, you'll have 2 to 3 questions that test you on subnetting and variable length subnet masking. So we'll get to that. Okay, so we want to understand addresses, the classes of addresses, private addresses, and then subnetting. We're not going to deal with DHCP tonight. We dealt with that earlier. That's just a process to get addresses out there. So what we want to understand, some very basic things up here that you want to understand. First of all, an IP address is 32 bits. And we see an example down here in binary of 32 ones and zeros. That is an IP address, okay? That IP address has 2 parts to it, a network part and a host part. And the network part is first, the host part is second. Now, there are exceptions to the, not to the order, but to not every address has two parts. There's a few limited exceptions. Those won't be a problem. You'll understand exactly why those are exceptions when you get to those. But for right now, when we're addressing workstations, when we're addressing interfaces, every address, 32 bits, has a network component and a host component, and the network component is first. Now, if we didn't have the advantage here of seeing the bits here in blue, we would have no way of knowing where the network portion stopped and where the host portion began. And in order to be able to know that, because obviously you're not going to have people give you an address, oh, here's 172.16, 122.204, and write part of it in blue and the other part in some other color. And if they did, it wouldn't work anyway in some cases. So it's just, you know, obviously just for illustration examples here. So we need something else to tell us where this division is between network and host. And that something else is a subnet mask. And that will be all ones binary up into the boundary and all zeros binary in the host. So we could put the mask, if we did right here, to have indicate this boundary in decimal, it'd be 255.255.0.0, or it would be 8 ones here, 8 ones there, 8 zeros, 8 zeros. So that's IP addressing at its simplest. And if we always had the division between network and host on what they call a byte boundary. So that's a byte boundary, that's a byte boundary, that's a byte boundary. If we always had it on a byte boundary, things would be fairly straightforward. What we'll see later, though, when we get into subnetting, we're not always on a byte boundary. Now, in order to understand subnetting, you have to understand that there are 3 classes of addresses to which subnetting can apply: Class A, Class B, and Class C. And by default, a Class A address has the first 8 bits network, Class B, the first 16 bits network, Class C, the first 24 bits network. This was how IP was originally written, and there was no mask. You didn't need a mask because, let me just show you why, and this right here. If the first byte was 1 to 126, it had to be a Class A. That was the rule. If the first byte was 128 to 191, then it was a Class B, and the first 16 bits, of course, were network bits. And if the first byte was 192 to 223, it was a Class C. Now, obviously, this is once it's translated into decimal, but in binary, because the router is getting binary. How does the router know? Well, if the first bit is a 0, then the first byte has to be between 1 and actually 127, but it'd be 1 to 126. If the first 2 bits are 1, 0, then you have that range. If the first 3 bits are 1, 1, 0, you have that range. So if a router looks at an address and you don't have the concept of subnetting, all the router has to do is look at either the first bit, the first 2 bits, or the first 3 bits to determine if it's a Class A, a Class B, or a Class C. So if it's a Class A, the first 8 bits are network bits. If it's Class B, the first 16 bits are network bits. Class C, the first 24 bits. That's how it was originally designed, way back when, right after we had covered wagons. Okay, that's how it was designed. And so if we were given this here, we can then figure out what class of address this is. If we're looking at this as the default, and there's no mask that goes with it, then we'd say that's a Class A. Network is 10.2.1.0. Host is 0.0.0.1. So if you're defining the network, you zero out the host bits. if you're defining the host, you zero out the network bits. This is a class B. This is a class C, a class C, a class B, and this is not a valid address. You cannot have an address that has a value greater than 255 because you're representing 8 bits. And if all 8 bits are ones, the value is 255. So there can't be a value more than 255. And here they're showing you the answers. Okay. All right. We also want to know about within these classes some private addresses. These are addresses that are never assigned to anybody on the internet. These addresses are addresses you can assign to yourself. So within your organization, you can use any of these address ranges, tons of address ranges. The problem is that when you assign your local PCs these addresses, your PCs cannot get out on the internet with these addresses by themselves. Something else has to happen. And we will show you that something else. In fact, we'll get to that not this week, but probably the next couple of weeks, we'll get to Nat and Pat and show you how you translate these addresses into a routable IP address. But these are not routable. I had a sort of interesting situation with one of my former students. He was creating a tunnel between a law office and one of their branch offices, I think it was. And so what he did is he went home and he got the whole thing figured out. And then when he tried to apply it at the business scenario, it didn't work. And so he called me up and says, "What's going on?" Asking, "What's the address?" And he said, "Oh, you're using private IP addresses. Inside of your little lab environment, they work just fine. They're routable inside the lab. But when you put it into the real world, they're not routable across the internet." Okay. So what we're going to end up doing is we want to learn how to subnet. And the reason is because if we don't subnet, we don't have efficient address allocation. Okay. So when you get assigned an IP address of, let's say, 192.168, I'm sorry, you would not be assigned. This is a private address, but what happens is this. In the slides, Cisco would use private addresses to demonstrate things, even though the private address was not routable on the network. The reason that they used private addresses is that they found if they used real addresses in their slides, the students would go home, use the real addresses, and then that would cause problems because people were actually assigned those real addresses. So they use private addresses in the slides, even though this would not work. This is not something you would do if you're trying to get out on the internet. Okay. And we're going to see how we get to that conclusion right there next. Okay. So now I'm going to switch over to, let's just go, I want to sort of file close. Let's see if this works. Yes. Okay. So what we end up wanting to do for efficiency is we want to subnet our environment to meet the requirements of our environment. And let me go up here because I'm catching this in the middle of this slide presentation to avoid a lot of redundancy. Okay, so if we subnet a /16, for example, what do I mean by a /16? Well, with a mask of 255.255.0.0, you have 16 of the bits are network bits, so we can write that as a /16. Okay, and so let's just look at this here. This is a table that you can refer to. If you change the /16 to a 17, you end up with these results over here. 2 subnets and all these hosts. Then if you go /18, 4 subnets, 8 subnets, 16, et cetera, et cetera, et cetera. Okay. That's just, you'll not need a table quite like this. You will want a portion of this table. You will want the table from about the /25 on down. And they're just showing you if you want to create 100 subnets with a /16, what would you have to do here? And you would then come over off the boundary, certain number of bits to pick up 100 subnets. And with the /8, you come over further because you're starting with more bits. So what I need to do here then is stop this share. And I need to go to a whiteboard, new whiteboard. This is always fun. So we know. Okay, all right. So what I want to do is I'm going to, let's see here. Let's put this out like that. Normally what I do is oh boy, this is tricky this way, but we'll just see if we can do it. What I would do is create the 32 bits. So I go, 32, and then I'm gonna do this like 32 times, and it's really, nope, it's not gonna work that way. Okay. I'll just do that and delete that. Okay. It's easier with a pen. So I'm just gonna go 1, 2, 3, 4, 5, 7, 8. Bear with me here. Okay, 17, 18, 19, 20. Thinking there's a way to do 21, 22, 23, 4, 26, 27, 28, 29, 30, 31, 32. Okay, so now let's do this. I've got all these bits here, and somewhere in here, I'm going to have a division between network and host. Well, let's first of all understand what we do to translate the bits into binary. And the way we do that, I think I can do this easiest with text up here. Okay, so if I've got the first, whenever I have a bit on, it's worth the value of the position. So if I've got a 128 position, 64, 32, 16, 8, 4, 2, and 1. Let me just go back there and move that a little bit. Okay, so now that's what I want to, the matrix I'm going to use, or the translation I'm going to use. So a 1 in any position is worth the value of that position. I now have 8 positions represented up there. So let's say I had 1, 1, this is in binary, 0, 0, 1, 1, 0, 0. Okay, bingo. So what is that? If I want to represent that as a decimal number, how would I do that? Okay, so what I have is 128 plus 64 plus 8 plus 4 equals what? Well, it's just a matter of doing the math, however you do it, right? 128 plus 64 plus 8 plus 4. If you have to, take off your shoes and socks, that's fine. You'll get a piece of paper when you take the exam, and you could simply do the math on the piece of paper. Eventually, you'll become more adept at this, and you won't probably need a piece of paper too often. But I'll tell you that whenever I took an exam, an IP or an IT exam, I always wrote across the top the 128, 64, 32, 16, 8, 4, 2, and 1, so that I could just put things down there if I wanted to. And actually, there's an even better little chart that I'll show you. But 128 plus 64 equals 192. 192 plus 8 equals 200, plus 4 equals 204. Okay? Does everybody see how I came up with that? So if I was going to represent those bits right there, that would be how I would do it, okay? All right. Now, and once we know that, let's just get rid of this thing here. Actually, I get rid of the whole thing. Okay. And actually now what I can do is I can get rid of, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's get rid of those. Delete. Okay. So now what I can do is, let's say I'm going to come up with an I'm going to put an address in here. I'm going to put an address of 204 dot, and I'm going to take these 8 bits out of here. Bingo, delete those out. So 204 dot. Can I actually get inside that? No, I can't. Text 204 dot. It's just so frustrating to move this around. It doesn't move around easily. There we go. 204.50. Okay, bingo. And now after the 50, what I have is a dot, and now I can do this very easily. Oh no, that didn't work. Okay, so I've got my spaces out here now. What I'm trying to do is go. What it makes it disappear. Okay. Well, let's just put that out there. Is 204.50 dot, all my dashes out here. And what I'm going to do is I'm going to just eliminate these and go with my. I'll tell you what, I'm going to go 204.50 dot. Yeah. I do want to do that actually. 204.50 dot lines. They have made this thing really difficult to do. I'm just trying to do it. Okay, we'll just do that. 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I don't like that I used 204 there. I actually don't. What I'd rather use is 160, and see if I can just put that over on top of it. Okay. Now you can't read either one of them. And I can actually select the 204. Okay. Now I can do it. 160.50. And we'll just move that up a little bit, hopefully. Okay. So I have an address 160.50 something. And I've got 16 bits here. First of all, what is the class of this address? Anybody want to?
2?
It's a class B address.
Oh
right?
yeah, B, sorry.
Yeah, that's okay. No, that's it's the second option. And a class B address has a default mask of 255.255. Okay, dot. It would end up being 0.0. Okay, that would be the mask. So let's say that someone assigns me 160.50.0.0 with a mask of 255.255.0.0. They've assigned me this one address. This is also, if we were to do this by way of a slash, it would be a slash what? It would be a slash 16 address, right? Everybody understand what I'm doing there? This 16 is the same as that right there.
Yeah.
Okay. So I'm going to take that, delete that. All right. They've given me one address, and on that one address, I can address how many hosts. One network, how many hosts? Well, here's what you can do. You can use sort of what I call your hand calculator, because when I'm teaching this in person, I put my hand up on the board and I go, if you go from here over to there with your hand, you put your hand on the byte boundary, that's 2 to the 8th power, and that is 256. Every time you move one more that way, you double it. So if I have 8 bits to use, I have 256 combinations. If I move over there, I now have 9 bits to use. 2 times 256 is what? 512. 2 times 512 is 1024, etc., etc., etc. And I get up to here, and what I end up with, if I have all of these bits available for host bits, I can address about 65,000 hosts. That's way too many to have on a network. So if they gave me this one address, and let's say I only put 200 hosts on it, well, I've got 65,000 plus actually addresses. I'm going to waste over 65,000 IP addresses if they give me this one address and I only put 200 hosts on it. Okay, that's very inefficient. So what I want to do is, let's say I have, 200 networks. Okay, and I have 200 networks, and on each network I have 200 hosts. So let me just write this here. So as for our reference, I have 200 networks, and each one has 200 hosts. Okay, that's my problem to solve. I've been given this address. Can I do it? Yes, I can do it. So let's look at this. The mask boundary right now is there. If I move it this direction, I get more networks and fewer hosts. Here, I've got one network, 65,000 plus hosts. I start moving it over, I end up with more and more network possibilities. So let's just put it right here. Let's put the boundary right there. I'm just going to draw that. So here, right here, this is my boundary right there between network and hosts. Okay, bingo. That's my boundary. Here, if I go from here to there, that's 2 to the 8th power. 2 to the 8th power equals 256 combinations. Now, there was a time when we couldn't use all 2 of those because one of them would be all zeros and one would be all ones. The all zeros was considered a subnet, an unusable subnet address, and the all ones was an unusable address too. That was just for early implementations. Right now, we can use the all zeros and the all ones. We have everything in between. So we have 256 different networks. Okay. Let me just show you how this would work. So now I'm in this byte right here. And here are my possible networks. The first one is 0. The next one is 1, then 2, then 3, etc. Okay, those are all possible hosts. I mean, networks that I could have. So I have 255, I'm sorry, 160.50.0, 160.50.1, 160.50.2, etc. On each of those is considered a subnet. And the mask, if I'm going over all 8 bits, would then be, for all of them, would be a /24. Oh, come on. There we go. /24. And the mask would be 255.255.255. Okay. So far, does this much make sense? Anybody have any question about this? This is still the easy part. We're on a byte boundary. Okay. So now what I want to do is I want a new whiteboard. I just want to wipe all this out. Let me just see if I can do all this. Bingo. That's easy. Okay. So now let's try a different situation. I'm going to put a router up here. Bingo, I've got a router. And on that router, I'm going to have three networks. I'm sorry. Yeah, I'm going to have three networks that come off this router, okay? I'm not trying to be fancy with this. It's just the way it's working out. Okay. So I've got three networks, router with three networks. On each network, I have 25 hosts. Okay. Right. So far, so good. Everybody with me, what I'm doing here. So
Yes.
let's say that now I'm assigned the IP address of 200.1.1.0. And of course, that is a class C address, which by default is a /24, which would have a mask of 255.255.255.0. So the /24 and that mask are the same. This is what I'm assigned. Everybody with me so far? Stop me at any point if this is not clear. I'm just gonna keep going here and then we'll take a break here before too long. Okay. So now this is what I've been assigned. Well, they've given me one network address. I've got three networks. So already I got a problem. I want more than one network. So what I'm going to do is I'm going to look at this in this way. I'm going to say I've got 200.1.1. But now I'm going into binary. Oh no. It keeps, is it erasing it or not? Yes, it is erasing it. I don't know why it does that. Okay. Okay, so 200.1.1.1, and I've got 8 bits out here. I have to draw them in. Okay. All right. So I've got this address. I've got 8 bits. If I move over 1 bit, how many possible combinations of ones and zeros do I have? Well, if I move over 1 bit, I actually have only 2 combinations. And you know what? I know I normally do this with 5 networks. So let me just do this just so that we have, let me just do this. We need 5 networks. Make this scenario make more sense. There we go. 5 networks, 25 hosts each. I'm not going to keep writing the 25 hosts each. I know this looks like something you found in your bathroom one morning, but this is actually 5 networks in a router. Okay. So if I go over 1 bit, the possible combinations that I have are simply, we go here, dot, they're simply 0 and 1. Well, that's only 2 networks. If I go over 2 bits, I have 0, 0. I have 0, 1. I have 1, 0. And I have 1, 1. Those are the 4 combinations that I have, and I've got 5 networks. So what I have to do then is go over 3 bits And let's see what we get. Go over 3 bits. I can make this work. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 1, 0. And 1, 1, 1. So I should have 1, 2, 3, 4, 5, 6. I'm missing 1. 0, 0, 1, 0, 1, 1, 1, 0, 0. Oh, I've got one more to put right here. 101. Now, 1, hang on. 0, 1, 0, 0, 1, no, 1, 0, 0. Okay, there we go. 0. 1, 0, 1. 1, 1, 0. And then I'm down here. Now I should have 8, right? Oh, I got 101 twice. 0, 1, 1, 1, 0, 0, 101. Okay. Yeah, there we go. There we go. So now I have 8 combinations, right? Does everybody agree that for 3 bits, those are the possible combinations that you have? Okay. Now, if those are my network combinations, what do those translate into in the way of network IDs when I translate that into decimal? So 200.1.1.what would equal all those bits plus the first 3 bits being zeros. All the host bits, of course, are going to be all zeros. This is 0. This equals what? 32. Does everybody understand how I came up with 32? This is what we go back to that, the values that I had before. If if 1 is in the a bit position at the far left is worth 128 and 64. This is a 1 in the 32 position. Okay. You have to assume that all of the host bits are all zeros. Okay, here we have equals 64 equals 96, right? Equals 128 equals 160 equals 192 equals 224. So far, does this make sense? So what you can picture is if we have the 255, 255, 255, you would have that for the last octet. That would be your decimal value for the 8 different networks. Let me give you an example here. Let's address this one network right here using the information we now have. This first network here, we're going to use the first combination, which is all zeros. So it's going to be this 200.1.1.0 slash, now how many bits am I going over? Well, I'm going over 8 plus 8 plus 8 plus 1, 2, 3. That's slash 27. Does everybody see that? And if not, it's fine. We will just keep hammering on it, and eventually this will make sense. But this is subnetting within the byte boundary. In other words, what I'm doing when I do this up here is I'm putting the byte boundary right there at the third, between the 3rd and the 4th bit. And that's actually the 27th and 28th bit. So that's for this one here. Now let's go over here. If I'm going to address this network here, here's my next one, 200.1.1.32. /27. Do that. Okay.
Could we backtrack a bit?
What was that?
Could you backtrack a bit? How did you get the 3 bits to get 27?
Okay, how did I get the 3 bits to be 27? Okay, so we've got 200. The 200 is for the first 8 bits, right?
Right.
The first 8 bits in decimal are represented by 255, correct?
Correct.
Okay, the next 8 bits, that takes us, we go another 8 bits, we're now at 16 bits total, correct?
Correct.
We go another 8 bits, we're now at 24 bits. So at this point, I realize that, you know, it's hard, but basically if we stopped right there, we've gone over 24 bits. But now
Yeah.
we're going 3 more bits. We're going 1, 2, 3. And so now the line between network and host is right there. So you've got 8 plus 8 plus 8 is 24, 25, 26, 27.
Got it.
Okay?
Yeah. Thank you.
Okay. Now, why did I go over 3 bits? Because if I go over 3 bits, I have 8 combinations here. 8 combinations, and I have 5 networks, so I needed to go over at least 3 bits to pick up those 5 networks. If I only had 3 networks, I could have only gone over 2 bits, because with 2 bits, you have 4 combinations, and I could have addressed the 3 networks. So what I've done is I've gone over 3 bits so I can address 5 networks. That leaves 5 bits here for host bits. Well, let's just make sure that I have enough bits left over to address 25 hosts. So here's how I would do it if I'm not, you know, trying to shortcut it. I know that if I went from here to there, if I had 8 bits, 2 to the 8th power is 256. So if you can remember that, 2 to the 8th power is 256. Every time you move over 1 bit that direction, you reduce it by 1, you cut it in half. So 8 bits is 256, 7 bits is what? 128. 6 bits is 64. 5 bits is 32. So I have 32 combinations here, and I only need to address 25 hosts. So I have enough combinations. Another way of saying it is 2 to the 5th power is 32. And all I have to do is minus the 2 unusable. We'll get to that eventually. But basically, I have enough host bits here to number all of my 25 hosts. Let's look at, let's just take this network right here. Okay. Actually, let me do one more network. I'm going to do this one right over here. This is the 3rd network, and I'm going to use the 3rd option. So this is 200.1.1.64//27. By the way, the mask, if I had to put it in decimal, would be .224 up here. It would be 255.255.224. This is one of the frustrations I have with a whiteboard like that works like this, not one that's where I have an eraser up there in front of a classroom. It's very hard for me to just modify this up here. But if we're going to go over /27, then it's 255.255.255.224. Anyway, so now I've got 3 networks addressed. 3 networks addressed. I'm going to look at the hosts on this network right here. Okay, let me just see, can I move that around? I think I can move that. I'm just move that up here a little bit so that I've got some space underneath, that's all. Okay, so on this network, and this is something you want to, this is my little, this works into a shortcut, by the way, when you're trying to figure things out. On this network, the first host, let's define the first host. It's 200.1.1. Well, 30, if I did dot 32, that's the network ID itself. But if I add one bit, if I turn one host bit on, that's dot 33. That equals the first host. That is one more than subnet ID. Okay? Does everybody see how I get that? 200.1.1.33 is the first host on the network. Let's just do this here. I'm going to put this up here. So 200.1.1.32 equals the network ID. That's what I set up above. That's what I decided. This network is the 200.1.1.32. I'll do a /27 in there. That is the network. 200.1.1.33 /27 is the first host. 200.1.1. Well, we don't want to go all the way to the end, do we? I mean, you don't want me to go 33, 34, 35, 36, because there's 32 possibilities and we'd run out of space and time. So we don't want that. I'm going to go to the last host ID, and that is 2 less than the next network ID. What's the next network ID? Well, let's just put it here. 64 is the next one. Mine's covered up, by the way, by something that they've imposed on this. So 200.1.1.62/27 equals last. Yeah, that's right. Last host. 2 less than next subnet. And then 200.1.1.63/27 equals the directed broadcast. And then you have the next network ID. Okay. Folks, this is fundamental to understanding subnetting. Okay? What I have right here. Once you have determined how far the mask is going to go over, you come up with a network ID. Just put network ID there. Network ID. Okay? You add 1 to the network ID, 1 more than the subnet ID, and that's the first host. You then determine what is the next network ID that's available. -2 gives you the last host. -1 gives you the directed broadcast. Now, look at something here. I want you to see something. We're going to see a relationship that's existing. What is the relationship between this network ID and that network ID? What is the difference numerically? You can all do the math. It's what? 32, right? Everybody sees that 64 minus 32 is 32.
Yeah.
96 minus 32 equals what? 64. Or 96 plus 32 equals 128. 128 plus 32 equals what? 160. 160 plus 32 equals 192. Isn't this sweet? Now, let's find out, well, how did I come up with that magic number of 32? Happens to be the relationship between all these. 0 plus 32, 32. 32 plus 32, 64. This is wonderful. If I only had an easy way to figure out what that magic number was, well, it is very easy, because what is the value of these bits up here? The first one's worth 128. the next one's worth 64, and bingo, the next one's worth 32. In this case, that's where I have my division. Next one is worth 16, of course. 8, 4, 2, and 1. Let me just run this out. Okay, so bingo. Maybe I can delete that, get that out of there. Good, get that out of there. Okay, so clean it up a little bit. Okay, so the division between network and host is right there. The value of that bit is 32. And wow, that gives me my network IDs. Magically, the first one is going to always be the 0 network. Then I go, multiples of this. 0 plus 32, 32, 32 plus 64, et cetera, et cetera, et cetera. So once I determine where the mask boundary is, I look one left and I say, the mask boundary is here. That means that the first network is going to be 0 and the next one's going to be the value of that, and they're all going to be multiples of that. Okay. Then I come over and I say, okay, now what are my hosts? Well, I take my network ID, add 1. I've got my first host. I add that magic number to get the next network, and I minus 2 to get my next host, or my last host. Minus 1, get my directed broadcast, and that. So now that you've seen this little formula here, let's do this. I want you folks to, okay, we're working again now. Now we're going to work with this network here. Okay, now I have my little formula. And I'm going to work with this network. So now I'm the network administrator. I've figured some things out, and I'm going to address all of I want to know what the range of host addresses is on that network right there. So I go, okay, the network itself is 200.1.1.64/27. The first host, therefore, must be 200.1.1. What?
128.
Okay. The first host is one more than the subnet ID.
Oh, 96.
You were saying you were looking at the binary. So no, the first host is one more than the subnet ID. What's the subnet ID? 64. The first host is 65.
Oh, never mind.
No, it's okay. Now, what is the last host? It's 2 less than the next network. Well, what is the next network? 200.1.1.96 is my next available network, right? So my last host is 200.1.1.94. And my directed broadcast is 200.1.1.95. Next network, 96. Once you get this little, this is the first time we've seen this, but once you get this down, subnetting within this byte right here becomes very, very easy. Okay, so I've shown you a few things that will make this actually pretty easy to do without having really even a calculator, hardly. I mean, you can use I use what we call my hand calculator. Okay, so all I need to know is where am I going to place that boundary between the network and host, and then I look one to the left of that, and that is where I'm going to get my subnet IDs from, whatever the number is that lines up with that.
I think it'd be easy to explain if you put zeros in those last 5 bits.
I understand. So
Then you put in your numbers below the 0, 32, 64.
I understand that, and that's the problem that I have with this. I'm trying to do things up here, but let's just do it so that you get a little better visual. Okay, so I've got 0, 0, 0, and now okay, actually, I don't want to put a dot there. I'm going to put this, okay, because I know I have to go over 3 bits, and then I've got 0, 0, 0, 0, 0. Okay. So those are the 8 bits, right?
Yeah, then on the 3 bits, just put in what you had in before.
Yep, go 0, 0, 1.
And what number is that? Combined with the 5 lower bits. Oh,
Yes, and this is what I would do. This
Yeah,
is how I do it when okay. So 0, 0, no, 0, 0, 1, 0. 1, 2, 3, 4, 5.
yeah, then what number is that?
Okay,
Each-
so what number is that? So what's the value of a 1 in the second position?
So that's you have to,
Okay,
mean-
look up here. Here we
64.
have it right here, you see?
so that's 64.
Yes. So what is the value of a 0 in the third position? It's 0, right? 0, 0, 0 is 0. Because you have to have a 1 to have these things kick in. Otherwise, it's 0. So 0, 0, 0 is the first one. 0, 0, 1, this is binary. That is 32. 0, 1, 0 is 64. What's the next one going to be? 0, 1, 1. Like that. And what is that? 64 plus 32, correct?
So this, to me, this is like a question on Jeopardy when they give you a binary number, then you got to sit there and go, okay, 1, 2, 4, 8.
Exactly.
So
Yes. Let me,
if I had to do this on Jeopardy, I couldn't do it.
okay. No, here's what you do.
I can't.
Here's what you do. Across the top of your paper, you write this right up here.
Yeah, I agree with you 100%.
Okay, well then, let me show you how, let's come down here. Okay, so if I gave you 32 bits, you just have to do it 4 times. But let's say I gave you the first 8 bits. I'm just gonna do this randomly. What? Okay, I just gave you 8 bits. Didn't know I did, that's 9. Is that 8 bits?
Yeah,
That's 8. Tell me what is what does that equal decimal?
I have to go.
Well, let's do it. We'll do it together.
1.
What's the value of the first one? What's the value of that right there?
Well, I go the other way, but it's fine. Okay, 128.
Okay, plus what's the value of that?
0.
No,
Plus
no, what's the
32.
value of the next one?
0.
64.
Okay, you have 128 plus,
42,
that's 30, isn't this the 32 bit?
22, yes.
So 128 plus 32 equals what?
160,
160. What's the value of that bit right there? That's the 8 bit, correct?
correct.
So it's 168 plus 1. 68 plus 1 is how much? 169. I'm just making some space there, okay? Does everybody see how we get to 169?
Yes.
Okay, we're gonna do a little practicing right now. I'm just making these up as we go along. Okay? Give me the decimal number. And this, by the way, you need to be able to do this for the exam. So if you can't do this, you need to keep practicing until you can do it. Okay? So the first one's 128 plus what? 64 equals what?
192.
192
Plus
plus
1 is 3.
plus 2 plus 192 plus 3 equals what?
195.
195. Okay, that's great. 0, 0, 1, 1, 1, 1, 0, 0 equals what? I'm just making things up.
64 plus 32.
Nope, hang on.
I'm sorry, 32 plus, because you had that bar there. Move the bar, could you move the bar over? Then you had the bar between the 32 and the 16, and I
did
see-
before. The bar, I know this bar, I put this bar here because of the problem
Yeah, I
with.
understand, but
Yeah,
if I'm doing it quickly, I see that bar there, and I go, okay, so
We'll get that bar out of there. I can't get, let's see, I can't get the bar out of there right now, so,
okay, that's fine.
okay,
The
So, if
60?
you go from the top,
okay,
the first 4 digits, 0011, I would go 32 plus 16.
it's 48, right?
Yeah. Then
Plus
next
8 is
you take 8 plus 4, whatever that is.
8 plus 8, 48 plus 8 is 56. Plus 4 is 60. Someone just said that a little bit ago, right? I can't write in there now because I've kicked out of this thing. Okay. Let's do this. This is good practice. what I'm going to do now, so that we don't have this issue here, is I'm going to put this across the top, 128. Okay, there we go. There's our reference. Okay. What does that equal?
64 plus 32.
Nope. Look at the what do you have
Yeah.
there?
64. Yes. No, I'm sorry. 64 plus 16
Yep.
plus
86.
8 plus 2. 4 plus 2. Sorry.
What was it? I think 86, right?
86.
Whatever
Yes.
that is.
Is that right? 86?
Yeah.
Yes.
Okay. I'm just making up these combinations. We should be able to sit here the rest of the evening and do this and bore ourselves to death. I mean, have a great time.
128 plus 64 plus 32 plus 3.
227.
227.
Whatever that is.
27. Okay. Great.
I think everyone understands it.
Okay. I just wanted to make sure.
Yeah.
Then,
I agree. Since you don't get a calculator, just write on the page 120, 64, and just sit there and
Okay.
grind through
now
it.
okay, so now you're writing this. Now let's try this. I'm gonna wipe everything out. Okay. Wipe everything out. Wipe everything out here. Get rid of our monster, whatever it is up there. Okay, boom. Okay, now. Here's what we're going to, oh, wow. Okay, so what I normally would do if I were trying to show this, and you know what might work better? Let me just see something here. I'm just, that's just the whiteboard. Let me do this. I'm going to share an Excel. I'm going to try and do this in Excel and see if I can make this come together easier, because I'll have the lineup of all the different things. So I'm going to come back over here. I'm going to, whoops, get down my Zoom meeting. I'm going to get rid of this whiteboard. Get rid of my whiteboard. I'm going to share my screen. There we go, Excel. Okay, can everybody see my Excel spreadsheet now, right?
Yes.
Yes.
Okay, so let's do this. 128, 64, 32, 16, 8,
Space.
4, 2, 1. Okay, so far so good?
Yes.
Okay, I'm gonna do a format, cells, border, boom, boom. Okay, now, actually format, let's do a format, cells, border, and let's go there. And maybe we can see a little bit better. And I'm gonna bring down some. Okay, all right. So now let's look, because now I can flip around between cells. If this is the last byte, okay, of the whole thing, and I have I'm using the 128. I'm coming over 1 bit. How many networks can I address if I use 1 bit? I can address 2 networks, correct? Okay, hang on. Let's try this. What is the mask? If I've got a mask of this, I think I can do this here. 255.255. No, I don't want to do that. 255, yeah, 255, 255. Okay, consider there's a dot after each one. I can just put a dot there. No, it doesn't show up. Okay, so I've got, some number up here, 200. We'll go my 200, 1, 1. Okay, and the mask is 255, 255, 255. Okay, so what if I change the mask boundary to this right here? What are the number of networks that I can address if I have 1 bit? How many combinations of ones and zeros can you have with 1 bit?
2, 0 and 1.
Okay. Now, what happens when I go over to 2 bits? How many combinations do I have?
Is that 4?
4. Now, if I go over 3 bits, what did we see? How many combinations do I have?
8,
4 bits,
16,
5 bits,
32,
and 6 bits,
64.
64. Okay, so let's put this way. I'm gonna put this right here. This is the number of nets I get. All right. Now I can't come over into here. We're not worried about that because you can't use more than these. You can't go over more than this here because you don't have enough host bits. You always need 2 bits for host bits. Okay. So I'm gonna go here, number of hosts. If I come over 2 bits, that leaves me how many bits? It leaves me 7 bits for host bits. Well, I told you that 8 bits is 256. Well, 7 bits would be, I have how many? I have 2 to the 7th power, but minus 2. 2 to the 7th power is going to be what? 128. I'm going to have actually minus 2, 126. How many hosts if I have 6 host bits?
2 to the 6 minus 2.
It would be 64 minus 2, right? This was 128. This is 64. So it's 62, 30, 14. How many hosts can I do here? 2 to the 4th power is what? 16? Wait, I've got 1, 2, 3, 4 bits. So if the mask is there, I have 2 to the 3rd power, I have 8, I have 6. Okay. And here we have 2. 2 hosts. Okay. Number of hosts. So is everybody with me so far? That's how many hosts. So if I give you a mask, okay, now let's look at what is the mask. I'm going to come down here. Actually, let's extend this out a little bit, extend that a little bit. Okay. What is the mask decimal? So if I come over 1 bit, it's dot 128. Dot 192. Dot 224. Dot 240. Ah, no, don't do that to me. Excel's trying to, I got to format that cell. Format this, okay. No,
Put a one after it, 240.
well, no, if I do, it's not, I don't want you to see 241, format
We'll
cells.
understand.
Huh?
240.1. We'll understand.
Okay, I was just trying to, I should be able to do that though. Why I can't do that? Okay, 241. Well, we'll go
Point one.
X.
240.
I'll do that. X 240. Okay. 240. Okay. What's it going to be here?
248.
248. And what's it going to be here?
252.
252. Okay. Now, what is the mask in bit count? This is a /25. Come on. Oh, it won't let me do that. Okay. What's it doing here? Format, cells. There we go, number. It's just going to be text. I have to be able to put text in there. There we go. No, I didn't want to do that. Trying to select it. Okay, I'm trying to select these cells. Okay, let's see if it'll let me do it. Slash. No, that's what we do it. Let's do this. All be text. Okay. Now I can go back here and take this and do this. Okay. And something else I can do since I'm doing this. I can center it all. That's all nice. Okay. Okay. So now the mask binary. It won't let me put a slash in there. Oh, okay. Oh, darn. Why won't it let me put a slash character? Okay, I'm just put the number in. Then it's 25, 26, 27, 28, 29, 30. Ah. Bingo. Okay. Format cells. Border. Okay, bingo. All right. That little thing that you see on the screen right there, this is just for our own little example to delete all that. That you see on the screen right there is something you can take, if you can remember all this and write it out before you start to take your test. You have all the numbers for the last byte, for subnetting in the last byte. And some of this helps you when you're subnetting over the last 2 bytes, but that right there will let you subnet over the last byte. Okay. So for example, if someone gave you a problem, here's the problem. You have, someone gives you the address 201.7.16.0, and they're giving you a /24. That's a class C address. Everybody okay with that?
Yes.
Okay, they tell you that you have to address let's see, 10 networks. You have to have 10 hosts. Okay. And they want you to tell them what is the range of hosts on 3rd network. Okay. This is a real life example of what you would get on the CCNA exam and in real life. Okay, so let's look at this. I've got this address right there, 201.7.16.0. Okay. I want to have 10 networks possible. How many bits do I have to come over to pick up 10 networks?
Well, 2 to the 0 is 1.
16.
2 to the 1 is 2. 2 to the 3 is 8. 2 to the 4 is 16.
Right.
So
So right there, does that let me, if I only come over 1, 2, 3 bits and have the boundary here, I can only address 8 networks, right?
So you need 4 bits.
So I need 4 bits. So what is the mask that goes with 4 bits? Okay, so I'm going to determine my subnet, the new subnet mask I'm going to use. Okay, it's going to be 255.255.255. What? 240. Does everybody see that?
Yes,
That is right.
right.
You know, the best way to do these things is
No,
know how to derive it. What's like what I just said, you need 4 bits. So you need to cover 10 hosts. 8 won't.
that's
You
what I
get-
just did. I just
Yeah.
said you go over
but-
4
but
bits.
What I'm trying to say is you're making us memorize it.
No, you don't have to.
derive
You
it.
don't.
You don't have to memorize it.
Well, okay, so if you can do 2 to the power in your head, that's fine. But a lot of people can't. The other thing is, you don't have to memorize this. I don't have this memorized. What I have memorized is I know that if I go over 2, if I go over 1 bit, it's 2. I can figure that out. 2 to the power of 1 is 2, and I double it. So I just double. I didn't memorize anything.
I know, but 2 to the 4 people can do. Once you get beyond 2 to the 7, 2 to the 8, you have to sit there with a pad and pencil. But if you know,
What I'm saying is you can fill this out before you start your exam simply by knowing a couple numbers. If you move over 1 bit, how many host bit does that give you? How many combinations does it give you? 128.
I'm not gonna argue, but you have your way and I have my way.
Okay.
My way is to derive things. So I don't have to.
If that works for you, I'll tell you this. If you take IP subnetting from 10 different instructors, you'll get 10 different methods.
That's fine.
Okay. And I'm serious.
That's why I'm confused about subnetting right now.
What's that?
That's why I'm confused about subnetting right now, because I've heard it from several different people and everyone has their own technique.
Yes, everybody has their own technique. And so you have to find out what works for you. I'm giving you, this is a valid chart right here, or a little, chart, we might say.
Can I show you, explain how I would do this? It only take 20 seconds to answer this.
Go ahead.
Okay. The fact that we had to have 10 nets, that takes 4 bits.
Okay.
That leaves 8 bits left for the host.
No, it doesn't. It leaves 4 bits left for the host.
I'm sorry. Yeah, you're right. 4 bits left. 4 out of 8. That leaves 4 bits. So how many hosts can I do in 4 bits? I go 2 to the 4th. That's 8. Gee, it won't work.
No, 2 to the 4th is 16.
Okay, 2 to the 4th is 16. So it'll fit.
Yeah.
So the range of hosts, you say you have to minus 2, right?
Right.
So that takes off 2. And just for word of information, AWS takes off 5. They won't be on this test, but because I've also taken the AWS test. So
Okay.
this is how I would do it. So like you say, everyone has their way.
Okay.
Which
So
is fine.
I'm giving you this as a tool, not as this is the only way to do it. Okay. And the other thing is, so look at this range of hosts on the 3rd net. What is the 3rd network?
So you have to you would have to take
Okay, so let me show you how I come up with the 3rd network. Okay. I know that my boundary between network and host is right here. That means that the magic number for me is 16. I know my first network is 0. My second is 0 plus 16. My next one is 16 plus 16. So my third network is 32. Okay, that's my third network ID. I would put it up right here. Let me just put it over here. Range of hosts and third network. And the network ID is 20. What the heck have I got up there? 201.7.16. The third network is 32. And the mask, what is the mask that goes with that? Slash what? If you look there on the chart, 28,
28.
right? So that's the range of hosts. So that's the third network. That's the third network there. First host is 201.7.16.33. Okay. Now I'm going to go to the last. What is the next subnet ID? What do I add? My magic number to 32.
48.
48. That's my next network ID. And so my last host is 2 less than that, 201.7.16.46/28. And the directed broadcast is 201.7.16.47/28. So again, you know, I understand what you're saying, Roger. What works for you? I've had people explain IP subnetting to me in a way that didn't make any sense to me. I've also seen other shortcuts that work for people. I've seen people put up, I've had students come up and say, well, this table here, this works for me. And I look at it, it makes no sense to me, or it's like it's way too much for me to deal with. It's like, okay, that works for you. When I actually write out a table like this, I don't write out the full table. I actually write out, if I were to write this table out, I would say, I would go here, I'd go nets/hosts. I don't know why that's, I got caps lock, that's why. Caps lock, okay. I'll go net/hosts. And then over here, I would say 2/126. So I would end up putting these two into one bar, and then I would do all this down in one bar too. So instead of mass decimal and mass bit, I would go, the mass decimal is 128, and that decimal is going to be 25. So I would essentially then eliminate these two rows. And again, that's just the way that I would do it if I wanted to have this thing. And I find that when I have this up there, then when I get into subnetting, so for example, can you tell me, Roger, what is 2 to the 12th power?
Well, I have to sit down and figure it out.
Okay, well, I can tell you what 2 to the 12th power is pretty quickly. You know that? And I don't have it memorized. And the way that I do that is I know that 2 to the 8th power is 256, and then I just double it 4 more times.
Well, that's fine. Yeah, that works too.
Yeah, so that's what I'm saying is, once you see the relationships here, then you can, because you're not only going to have to subnet class C, you're going to have to subnet class B as well. And the other thing, when you get into route summarization, this will somewhat help you in route summarization as well. So it'll make some sense there. But the main thing, if you understand that row right there, that's the main thing you understand. From there, you can work it into binary and into decimal. It's just more tedious. And all this does, all this whole little, graphic there does for you is give you less thinking that you have to do on the test if you write that out and put it at the top of your paper to begin with. But whatever works for you is what you should do, literally. I mean, like I said, every instructor I've taken IP subnetting from does it differently. So
Well, my preference is just to understand so that 10 years from now, I can go, oh, I don't remember the chart, but I can sit down and derive it.
Yes. If you remember, that you have to know, okay? That's just the way it works. If you know that, you can figure all the rest out.
Yeah, that's how I do things. I don't want. I'm not too very good at memorizing things, but I remember how to derive something, and I sit down. Even if I were to take the test, I would sit down, recreate what you've done right in front of me, and I would always remember what you taught me. So
Okay, well, no, that's
Uh,
fine. And I understand, you know, I've seen people study for tests and they use, you know, various mnemonics. And I find that memorizing all the mnemonics is more trouble than just understanding the material. For me, but for other people, it works. But I once walked in on a lady that was studying for an exam, and she had mnemonics all over these two whiteboards. It was two big whiteboards in front of the class. She had mnemonics all over the place. I understood all the stuff that she was trying to memorize, but I tell you, I couldn't remember all the mnemonics. So I was like, well, that's whatever. So, whatever works for you. And I have to explain it in a way that I understand. And then if that, explanation gives you understanding, then you can go from there. But what we've just done down here is what you will see on an exam. You will see they give you an address to a 1716.24, and then they say, what is the range of hosts on the third net? That's it. If you have 10 networks, what's the range of the hosts on the third net? And you have to give them the mask and all that information there. And however you derive that is what is going to work, should be best for you. Okay. So I don't know if this helps. Would you like me to paste this into an email for you guys?
Yes, please.
Okay, I'm going to copy that, and I'm going to, so I'm going to stop the share, and I'm going to paste this right now so that I have it.
it's probably on the internet somewhere. I've seen them.
I imagine you'll find it in there somewhere, yes. Okay. Paste. Paste. There we go. And hopefully that came through. So now it's sent off to you. All right. Well, we've been going solid for a fun 2 hours. There's really not much more fun you can have than to study IP subnetting. I would suggest at this point that we just let you take the rest of the night to practice subnetting, and what I can do, I will be able to. Let me just see here, because I've got something I can pull up pretty quickly for you. My review questions, IP addressing and subnetting. I can send you, let's just do this, open it up. Okay, and then I'm going to come back here to the Zoom. I'm going to share this. Okay, so these are some practice questions that I have. We're not going to go through this right now, but, and in fact, Catherine, you didn't, well, some of these will be beyond you because we haven't covered NAT yet. But for example, you can go through this and just see if you can answer the question. And I've got 1, 2, I don't know how many I have in this one. And I believe at the end, here we go, all the way down. And then I have all the answers down below. So I'll send this out to you folks, and you can go through this. So for example, here's something that is another way of approaching it. That address is on which network, and you have to look at that and determine which network it is. Here's one that's just like what we did right there. 2 networks of 60 hosts. What's the mask you have to come up with, etc. So I'll send this out to you folks. And then, okay, there we go. And then you can work on that over the rest of our class time. If you have any questions, I'd be happy to help, you try and figure this out, or work on this a little bit more. So does that work for everybody? Because basically we're looking at, we've missed 2 breaks, so we would be, 20 minutes before we'd be back, and then we'd have another, little bit of time. So I think it best just to go ahead and send that out and let you folks deal with it. Any questions at this point?
The question you just highlighted, question 8, that's the one I have the most trouble with in subnetting. Like you're given an address. Sometimes it doesn't have like the side annotation. So it's just an address, and then you're given different addresses, and you're supposed to figure out where it belongs.
So you're saying the number 8 that I just had up?
Yes. That's my biggest problem with subnetting.
Okay, let me bring that back up and share again. And we'll go to number 8, okay?
Yeah.
I just happen to be there. We'll go to, yeah, you can see here, this is a more complicated one right there, but we'll go to number 8. The address 180.59.77.21/30 is on which network? Okay, now if you had my chart up, let me see if I have my chart up. Yes, I have my chart up. Can you see the, are you seeing what I'm looking at as far as the Excel spreadsheet again now?
No, but I have it written down.
Right, no, that's okay. So I'm not showing you my desktop. I'm just showing you. Let me do this. I'm going to do a stop share here. And now I'm going to share my screen. Okay, now do you see the Excel?
Yes.
Okay, and so now I should be able to flip over here, and now you see the questions, correct?
Correct.
Okay, so let's look at this. 180.59.71.21/30 is on which network? I'm going to flip back over to Excel and refer to my little chart here. Okay, so a /30 means that the boundary is right there. Okay, /30. So what was the network ID that do you happen to, I can flip back over to it.
21.
21? Okay, so the network ID is something .21. I mean, that's the host ID, right? For the last time. So if the boundary is here, what is the magic number? The magic number is 4, correct?
Correct.
So every network with this /30 is a multiple of 4. So if you keep adding 4, 21 falls on what network? Let me just show you how I would. So we know that the first network is actually a 0. Then we go 4, 8, 12, 16, 20. Ah, that didn't work. 20, 24. Well, now I've gone beyond 21. So the 21 falls between the 20 and the 24. So it's on network 20. Because I knew that number right there. I knew that with the mask boundary here, a /30 puts the mask boundary there. My magic number is 4, and those are my network IDs right there. Those are my first 1, 2, 3, 4, 5, 6, 7 networks. 8 networks. No, there's 7 networks.
Why is it 20 and not 24?
No, because what they gave you was, what they're giving you here, okay, this is an address. We don't know whether it's a host address or it's a network address. It's probably a host address, okay? .21 odd number, it's probably a host address, right?
Right.
So let's say that you're an IT help desk and person says, here's my address and I'm having trouble connecting. What network am I supposed to be on? Well, you'd have to figure out what is the network that that machine is supposed to be on. Okay.
Oh, yeah.
Okay. And if there's a /30 mask, then that means that that host 180.59.77.21 is on the 180.59.77.20 network. Okay.
Yeah.
And once you understand that, then now you have a point of beginning your troubleshooting. Now, in this case, this wouldn't be a PC because of the subnetting that's involved. This would be subnetting that would be involved for a point-to-point connection. If a person with a PC called you and said they had that address in the /30, the first thing you'd see is the /30, and you'd say something's probably wrong in the addressing just because you'd see the /30. But what you'd eventually realize is that that is a network that only has 2 hosts on it, and it's unlikely that one of them is a PC and the other would be a router. So it's just not a likely scenario in that regard. But it is a scenario in which if you were trying to address routers on point-to-point networks, and you had to figure out, your addressing scheme, where, you've got an interface pointing to another router, you have to figure out, like, what is the network that this interface belongs on. So if there are only 2 hosts on this network, on this /30, the 2 hosts are .21 and .22. Those are the only 2 hosts that can be on that network.
Okay.
Now, I realize I'm doing this quickly. If you want to be able to do it as quickly as I do it, then what you need to do is teach IP subnetting about 200 times, okay?
Okay.
I find that after you teach it 200 times, it gets easier.
So suppose this /30 wasn't there, and these options you have had a variable CIDR notations on them. So like how do you figure out where it belongs to? Say like the first one was, I don't know, /30, or the next one /24, the next one /16.
Okay, so what you can, it depends upon how someone's asking the question. They've got to ask the question properly. And if and I'd have to see what you're referring to, but I think what you're saying is you've got an address. They don't give you the /30, but they give it to you down here.
Exactly, yeah.
Yes.
And then you're asked to, where does that address fall? Right.
And then what you could determine sometimes, because what you do is you look at the alternatives. So I know that, okay, let's say that the /30 was here. This was one of the answers. Well, I would know that 21 could be on the .20 network on a /30. That's one possible correct answer, right?
Right.
But let's say the /16 had, and again, it's unlikely that it would be, well, let's say the .16 had a /30. Could it be on the could 21 be on the .16 network? If it was the /30, the answer would be no, it couldn't be, because on the .16 network, there's only 2 hosts, 17 and 18. And so it really depends upon the answers that they give you. And I'm approaching it one way here, but that's why I also have up here a question that, here we've got a whole different approach. Then up here, you've got a whole different approach. Okay. You see? And what you need to be able to do is come at it from any point of view. In other words, you're given the number of hosts and you're given an address space. How do you subnet that? You're given, a host address and tell me what network it is on, and you have options there. They can give you things in binary. What does it mean, decibel? So it just takes practice. Literally, it just takes practice. I was in one class, I was teaching this one class, and I would write 8 bits on the board binary. Okay. I would just be, like I did here, just write 8 bits on the board binary. And this one guy in the front row, he would give me the answer just like that. No, what's going on there? This stuff. He said, I teach this every day. I said, oh, okay, you teach it every day. And there was a story about one Cisco instructor that used to keep his checkbook in hex. Okay. Well, okay, these people are just showing off. That's fine. When you teach something, a lot, then you become much more adept at it. And you're not trying to become a master of this just to pass the CCNA exam. So you have to, determine how much studying you need to do to get to the level that you're comfortable. But I think you'll find that these questions will be good starting points, and then you can make up questions yourself, or just give yourself an IP address and a mask and just say, well, with that IP address and mask, what network would it be on? Yeah. So anyway, so I understand what you're saying, and practice is what will help that become clearer for you. Okay. And there's nothing more fun than practicing IP subnetting. I'm joking.
I know, because I've spent all day subnetting. Yeah, and I still don't get it.
It's okay. I understand. I was actually, I'll tell you a couple of stories. One, I was teaching my first class in which I was teaching IP subnetting. And this was for Novell way, way back a long time ago. I was teaching the Novell IP subnetting class. And I remember when I read the book, I was reading this, the textbook or the course book for the class. And I got to this one point and I was trying to figure stuff out. And then finally it hit me like, oh, that's how it works. And from then on, I had it. So I'm teaching the class, and in the class is an instructor who's sitting in the class because he's going to teach it. And as I start to write this one thing out on the board, he goes, oh, that's what they meant. And I just had to laugh. I turned around and I said, you came to the same place in the book that I did. So, yeah. And the first time that I took a class on IP subnetting, I was in the back of the classroom. I was an instructor at the time, but I was at the back of the classroom. And what the guy was saying didn't make any sense to me whatsoever. All these numbers up on the board. So I just said, I'll figure this out when I go home. And I went home and I wrote out on the top of my piece of paper, the first bit is worth 1, the second 2, the next 4, and nothing was working. Oh, wait, it's 128. Oh, okay, now. So, it's just a matter of, you just bang your head against the wall enough times and eventually it'll make sense.
I hope so.
Good. And I wish you luck with that. So, but I'm happy to, work with you on examples and practice questions.
Yes, I'll be grateful.
Yeah, no problem.
Because the exam I did, it's like 50% of it was subnetting in some shape or form.
Yes. Well, I hope that little table helps a little bit. But for when I teach this in person, I find it easier because I can, draw things on the board and erase and, use my hand to show you how you would move the mask boundary around and what the different effects would be. So to me, this is difficult to teach through slides. I've not seen any set of slides that really teaches subnetting well. And I've not seen any courseware that really teaches it well. It's just one of those things you have to grind on for a while.
Mm-hmm.
So.
Okay.
All right.
Yes.
I'm gonna send this out to you folks. I just sent that and I'll send the sample questions and you can work on that for the remainder of the class tonight. Okay,
Okay, thank you.
you're welcome. All right, so you guys have a good rest of your evening. I'll see you next Monday.
Okay,
See ya.
have a good evening.
You
Thank you.
too. All right, take care.
Sure.